Welcome everyone. The question that is shown on the screen, it is a question number 28. It is said a rectangular loop of area is given 4 centimeter cross 5 centimeter of wire carrying current 0.25 ampere is placed in a magnetic field electric vector 0.20 Tesla J cap plus 0.50 Tesla K cap such that the outward unit vector normal to the plane of the loop is 0.80 I cap minus 0.60 j cap. Calculate the magnetic moment of the loop and the torque acting on the loop. Okay, so here obviously one thing need to be noticed here. Okay, and here just see the area of the loop, that is a dimension, that is the length and breadth of the loop is given at one place, but the direction of the loop, that is 0.80 I cap minus 0.60 j cap, that is given in another place. Okay, so till now if I say this is the area, this is the area, let us say, okay, this is the area, this is the area, then the normal is drawn at a plane perpendicular to that of it. Okay, so here a rectangular loop is taken, obviously its length and breadth is given. So obviously if I write it down from the knowledge of the vector, what is that? That is the a vector. If I say this is the area vector can be written as magnitude of the area multiplied by the direction of the area, and this thing is basically gives you the direction of the area. Okay, direction of the area, and this thing basically gives you the magnitude of the area. So if I write it down, that is 4 centimeters, so it is 4 into 10 to the power minus 2 multiplied by 5 into 10 to the power minus 2. So this product gives you the dimension of the area or the magnitude of the area in meter square. Okay, and if I write it down, what is the direction of the area, that is we can say it is just the copy pasting that thing, 0.8 I cap minus 0.6 j cap. So 4 into 5 is 20, 10 to the power minus 2, 10 to the power minus 2 is 10 to the power minus 4. Okay, 10 to the power minus 4. 0.8, okay, 0.8 can be written as 8 by 10 I cap minus 6 by 10, obviously 0.6 is 6 by 10 j cap meter square. Okay, so this is the area. Now if I do the multiplication, obviously if I taking 10 to the power minus 4 outside of this bracket, then obviously 20 into 10 to the power 20 into 8 by 10, this gives you 16. Okay, 16 I cap minus 20 into 6 by 10, this gives you 12 j cap meter square. So that is the area. Clear? Now the magnetic field is given. What is the magnetic field? That is 0.2 Tesla J cap, 0.5 Tesla K cap. But at first we have to find it out the magnetic moment. Okay, that magnetic moment is M with the vector A, so that is I, okay, multiplied by the area vector. Current multiplied by the area vector, not the unit, area vector, the whole. So what is the current? Current is 0.25 ampere, it is already given. So 0.25 ampere means we can say this is 1 by 4, okay, multiplied by the area vector. So 1 by 4 multiplied by 10 to the power minus 4, 16 I cap, 16 I cap minus 12 j cap. Okay, and obviously after that it is ampere meter square, because current is in ampere and the area is in meter square. So if I just multiply 1 by 4 inside, 1 by 4 inside, so it will become 10 to the power minus 4. 16 into 1 by 4 gives you the 4 I cap minus 1 by 4 into 12. This gives you the 3 j cap ampere meter square. So that is the magnetic moment of the loop. Now next part, that is the what is the torque acting on the loop. The torque acting on the loop, which is basically denoted as a tau here, tau can be written as m vector cross b vector. Okay, m cross b. So m we have just calculated, it is 10 to the power minus 4. Okay, multiplied by 4 I cap minus of 3 j cap. Okay, cross b vector, that is 0.2 j cap, 0.2 j cap, 0.2 j cap minus 0.5 j cap. Okay, since the torque, obviously the unit should be Newton meter. Okay, unit should be Newton meter. Now 10 to the power minus 4, we can keep it aside like this. Okay, we can draw a determinant type of thing for doing the cross product. Basically we are doing like this. This is the I cap, j cap, and this is the k cap. So it is 4 minus of 3, no k cap is there, so it is 0. After that I cap is 0, but j cap is there, so it is 0.2, and the k cap is minus 0.5. okay, minus 0.5. so that is 10 to the power minus 4. okay, if I write it down, what is the I cap, then I cap will be 4 multiplied by, no, not 4, it will be minus 3 multiplied by minus 0.5. so it will be minus 1.5 minus plus, so 1.5. I cap equal to 1.5. okay, 1.5 minus 0.2 into 0, 0.2 into 0, so it is 0 actually. okay, 0.2 into 0. now we are doing for the j cap, so minus j cap, j cap means we have to do 4 into minus 0.5. 4 into minus 0.5 means minus 2, so you can see it is minus 2. okay, then 0 into 0, 0 into 0 is obviously 0. okay, obviously 0. okay, so plus k cap, so if I do the k cap is obviously 4 into 0.2, that is 0.8, minus 0 into minus 3, 0 into minus 3 is 0. clear? okay, so that is 10 to the power minus 4. okay, 1.5 I cap minus plus, so okay, so plus 2 j cap, plus 0.8 k cap, okay, Newton meter. so that is the torque acting on the loop. so magnetic moment we have calculated, and a torque acting on the loop, that is also we have calculated. Thank you, all of you.